So the next part, the next thing that we're going to do with applications of derivatives is called Newton's method. So this is section 4.8, and this is called Newton's method. So the idea behind Newton's method is that we're trying to find zeros of functions. So we're trying to figure out where does a function cross the x-axis, where is a function equal to 0. So the idea here is, where is a function equal to 0? This is the same question as saying, what are the zeros of a function? You could also ask the question, where does the function cross the x-axis? So these are all asking the same question. Now the way Newton's method works, and this is actually what your calculator does whenever it's solving the zero in the second calc, whenever you're trying to figure out where does a function cross the x-axis, this is what it's doing. What it does is it picks a point to start with. So the steps for Newton's method, and again this is what your calculator is doing, it makes an educated guess for x naught. So it makes an educated guess for x sub 0. So this is, this is called your initial guess. You just want to kind of pick somewhere. Next, you're going to find the tangent line at this x naught. So we're going to use the steps that we've done for a tangent line. Find the tangent line at x naught. Next, you're going to solve for the tangent line equaling 0. So this is, where does that tangent line cross the x-axis? Figure out that x value. Where it crosses is going to be your x1. Next, you'll find the tangent line at x1. Then you'll solve for where that tangent line equals 0. Solve for the tangent line equaling 0. Where it crosses is x2. And you'll keep on doing this. You'll do this over and over. So next you would find the tangent line at x2. Where that crosses the x-axis, that'll be x3. So you just keep on doing this method, and eventually you'll get closer and closer to the x value that you want. So for example, let's look at a couple different animations here. Hopefully you can see it. So this is saying the educated guess is at 1. There's the tangent line. Here's where it crosses the x-axis. x2 or x1 is here. There's your x2. There's a tangent line. You can see as you get closer, as you do more and more tangent lines, the x values are getting closer and closer to this point. So I know it went kind of quick. Let's try another one here. Oh. Here we go. So here's where we want, this is the x value that we want. We're going to start here with this x value. Find the tangent line, here's x1. Find the tangent line, there's x2. Find the tangent line, there's x3. Find the tangent line, there's x4. There's x5. You can see how close it is to our actual 0. Try another one here. There are no zeros on this one, so let's see what happens to Newton's method. We're going to start there. There's x1. Here's our tangent line, there's x2. There's a tangent line and x3. Tangent line x4, and we are back to where we started. So you can see we're just going to kind of be in this loop because this function doesn't cross the x-axis. So Newton's method doesn't always work. It only works for zeros, but let me try this one. So let's see, where are we going to start? We're going to start at 1. Find the tangent line. This is my x1. Find the tangent line. There's x2. Find the tangent line. There's x3. Find that tangent line. You can see as I intersect the tangent lines with the x-axis, I get closer and closer. So this is how Newton's method works. We try a bunch of tangent lines, see where they intersect, and those are going to get closer and closer to our actual value. Now how do we do this by hand? We actually use a chart here, and this is the chart that we're going to use. This is our xn's, so this is going to be x0, x1, x2, x3, etc. This is where we're going to start. Then we're going to plug it into f, plug it into f prime, and then find our next x. So we don't necessarily need to find the tangent line. We can just kind of use this chart, and this will help us find it. So let's go back to this one. Let's do example 1 here. Let's estimate a solution to cosine of x plus x equals 0, accurate to 3 decimal places. Decimal places starting at x naught equals 0. So we're going to estimate a solution to cosine of x plus x equals 0. Now it's important, if we're going to use Newton's method, that it has to equal 0. If the function doesn't equal 0, then Newton's method is not going to work. Now to do this problem, we're going to need to know what f prime is. So here f of x is cosine x plus x, which means our derivative is going to be negative sine x plus 1. So we're going to need those to plug it into our chart over here. So the place that we start with is 0. It told us that x naught was 0. F of xn, that's our function. Our function here is cosine of x plus x. And we just said that our derivative is negative sine x plus 1. These should be xn's, but it's okay. So, take our x, plug it into our original function. So if I plug this in, I'll get cosine of 0, which is 1, plus 0 gives me 1. Next, I'll plug it into my derivative. So if I plug this into my derivative, I'll get negative sine of 0, which is 0, plus 1, also 1. Now the next x value is going to be my original one minus this one divided by this. So 0 minus 1 divided by 1 is negative 1. And that goes here. So this value and this value are always going to be the same. This is how I'm finding the next x. Alright, next, cosine of negative 1 plus negative 1. That gives me negative 0.4599697. Next, I'll do negative sine of negative 1 plus 1. That gives me 1.84147. So my next x value will be negative 1 minus negative 0.459679, or 697, divided by 1.84147. So negative 0.75036. And that's also what's going to go here. Now I'm plugging in negative 0.75036 for my x value, so this will be cosine of that number plus that number, which I got to be negative 0.018923. Find my derivative here, so negative sine of that number plus 1, 1.68191. So then my next x value will be the first column minus the second divided by the third. So negative 0.75036 minus negative 0.018923 divided by 1.68191. Negative 0.73911. Now let's notice something here. The 7 has repeated. So this digit 7 here, and we can write it as our next one over here. The 7 has repeated itself. Now we're accurate to 3 decimal places as soon as we have 3 decimals repeating themselves. So far this is accurate to 1 decimal place because I've had 1 decimal place repeat. So we need to keep going until we have 3 repeating. So let's try more. So now I'm going to plug in the negative 0.73911. So I have cosine of that number plus that number, which gives me negative 0.4 zeros and a 4. Then I'll have negative sign of that number plus 1, which gives me 1.6736. So my next value will be negative 0.73911 minus negative 0.00004 divided by 1.6736. Negative 0.7391. So at this point, and we can put it down here again so we can kind of keep track of things, we've had 3 decimal places repeat. Well, actually 4, so that means that this is our answer. This is actually accurate to 4 decimal places, but in the process we did 3. So as soon as we get 3 decimal places repeating, we were done because the question asked for it to be accurate to 3 decimal places. So the answer to our problem would be the estimation is x equals negative 0.739, not 0, negative. So this was accurate to 3 decimal places because it repeated 3 decimals. So that's how we would do these problems. We just put it in our chart, find the next x value, and that'll give us a good estimation. Now, one thing that we need to concern ourselves with is, what if the question asks something like, give an estimation for sine x equaling x squared. Well, that's not a function equaling x, so you would change this. Change this to be sine x minus x squared equals 0, and then use Newton's method. So this would be your f, you'd find your f prime, and you just plug it into the chart. So that's Newton's method. Just use your chart. All we're doing is finding tangent lines where they intersect the x-axis. Once it repeats a certain number of decimal places, then you can say it's accurate to that many decimal places. Sometimes it won't work, so we should mention that. If it doesn't work, 2 things. So if this doesn't work, so if you don't get numbers that are actually going towards the same thing, if it doesn't work, 2 things. Try a different x0, or we conclude that the function has no zeros. So maybe your original guess was too far off and it's not going to work, or maybe the function doesn't actually have any zeros. So if you try a bunch of different x0s and they all don't work, there's a good chance that there are no zeros. So that's Newton's method. It's what your calculator is doing, so kind of cool.